Now, in addition to the section that the record can go in, which I think of as those 4 boxes, each record also has a data type. So think of this like the data types in Java or C. When you declare a variable in Java, you have to say if it's an integer, or a string, or a map. You have to say what data type it is. And in the same way, when you declare or create DNS records, you need to give them data types. And the data type does nothing else but tell us what type of data is in the record. What type of data is the name, and what type of data is the value. This is totally separate from where you put it. So you can have an A-type record in any of the 4 sections. You could put an NS-type record in any of the 4 sections. It doesn't really matter what the type is. It goes in any of the 4 sections. This is just telling us what the data is, and then the section tells us where it goes. So they're serving 2 different purposes. One is for data type. One is for the purpose of the record. So what other data types? For now, you only have to know 2. The A-type record has a domain name on the left side, like www.google.com. And on the right side, it has an IP address, like the number we saw earlier. So when you have an answer, for example, you can use this type of record. On one side, put the domain name. On the other side, put the IP address. That's your answer. And the NS-type record, as we'll see soon, is what you can use to encode one of those I don't know, but go talk to someone else sentences. So instead of writing that in English, you'll use this NS type. On the left side, you'll say a zone, like who they're responsible for. So for example, here's a name server that's an expert on .edu. So put .edu on the left. And their domain name, who they are, is this human-readable domain name. Put that on the right. So on the left, you say what they're good at. And on the right, you tell us who they are. So that's an NS-type record. We'll see that soon also. And as mentioned earlier, records can be cached. The reason why we design DNS using records as opposed to some other format is because every time you get a record, you can throw it in your cache. And you can just hold a big map of records and cache them for as long as you need. And records often come with TTL fields, which tell you how long it can be cached before the record becomes invalid. And you need to go ask again because the information might have updated. So those are the data types in a DNS record. Now, other types do exist. We won't talk about them here, but if you end up using DNS in the real world, there are some other types. For example, IPv6 is a newer protocol. They have their own record type. There are record types for redirecting. If you go to a website and it redirects you somewhere else, there's a record for that. There are records for email purposes. There are debugging records. There's all sorts of things you can do in DNS beyond translating domains to IP addresses, but we'll focus on its main purpose, and you can look this stuff up if you are curious. OK, so a little bit more about the record sections. It was someone mentioned earlier, but there are 4 sections, and each section tells us something about what the query is doing. So for example, if you have a question, you can put the record in the question section, and it will tell us what is being asked. If you have a direct answer, then in the DNS response, you can fill in this answer section with the answer to the query. And if someone is sending a request, like they're asking about the IP address, they can just leave this section blank because they're asking. They don't know the answer. And in the reply, you can fill in the answer section because you do know the answer. Now, if you don't know the answer, this is where these 2 sections come in. These 2 sections together will help us redirect the user to a different name server that can help. So if a name server doesn't know the answer, it's going to fill in these 2 sections to redirect a user to someone else who can help. So the information in here will be the code equivalent of saying, I don't know the answer. Please go talk to this name server. They are an expert at .edu queries, and here is their contact information. All of that stuff gets encoded in these 2 types of records. We'll see them in action soon, but here is a description of what they do. And as mentioned earlier as well, resolvers will cache records. This is why we designed DNS using records. And we like caching. Remember that DNS is very performant. It's very important that it's fast and lightweight. So caching is a big benefit toward performance. For example, you can cache records, so when you need an answer, you can look inside your cache, and if it's there, you don't have to make a second request. This is good because it speeds up clients, like our computers. They can cache answers and avoid doing duplicate requests. And it also reduces the load on the name servers. They have less work to do because every time we pull an answer from our cache, we save the effort of going to the name servers and asking again. So this is a win for everybody. We like caching, and everyone does it.